all right? This is an example of, you know, a gas lift, the gas lifted field. So these are the producing wells. As you can see here, we have 3 wells here, right? The production is going to the right side. So this is the oil or water, liquid. And then we have, so this is the cross section of the well, right? So we have what we call the production manifold. So these are flow lines, and then we have production manifold, all right? And then we go to the separation. We go to the separator, oil and gas, gas and oil separator. Then the separated water will go to the water treatment facility. It can go to the water injection or water disposal well, and the oil will go to the oil storage for the export line. And then the gas could be either also used, exported, sometimes back injected to the reservoir, or in this scenario here, we are using the produced gas, okay, in injection, in gas injection. As a matter of fact, you know, in this schematic also, we do have gas export line. So we are using, you know, this is a compressor, and then we are using some of the gas to be re-injected, okay, into the same well to use it as gas lift injection, okay? So this is a schematic of a production system. But now talking about pipeline networks and large networks, what are the challenges that a producer or, you know, a national oil company, an operator can face? So we have a problem of high operating costs of artificial lift wells. Sometimes if you are using, you know, electric submersible pump or PCP, then you will, you know, you really need a high power, and because these wells can be very deep, and then you need a lot of power for each well. So it's cost, okay? If you're using, for example, in this system here, if you're using gas lift, then instead of actually going and exporting the gas, using it for energy, you're actually re-injecting it to use it in the production. So this is additional cost, okay? So cost these days is very important. And looking into just the cost that will be consumed in artificial lift by itself, it's not really a small number. It's huge. We have loss of production due to insufficient or imbalanced artificial lift resources. So sometimes you have, let's say, in this case here, you have a gas lift system, but then the injection gas, so you are controlling how much gas goes to each well using the chokes, right? Sometimes the gas injection rate is not enough for certain wells. Sometimes we are over injecting it in other wells, and sometimes, you know, we have limited gas lift rate. And then how do I distribute this gas lift rate among the wells? What are the rules? What are the you know, the controls or the constraints that I need to consider when I distribute my gas lift rates among the wells? This is an important question. And if you have, let's say, 100 wells, 200 wells, then the problem becomes really complex, because you have faraway wells, we have wells, you know, connected to for example, production manifolds, and then 2 or 3 wells in the same production manifold is strong, 2 are weak, and so on. So it's really difficult if you need to make this right. And that's why you need an algorithm, you need a mathematical solver for you to help you in determining how you distribute the artificial lift quantity. We have a problem of high pressure wells domination. This is a known problem, especially if you have a mature field and then you are drilling new wells. New wells will be stronger, okay? And then when the production comes to the surface, the hydrocarbon will come with high pressure, and then this pressure will propagate to the production network, and then it can cause back pressure to other wells. Then this is what we call the high pressure wells domination. The strong wells will be producing, the weak wells will start to die. We have also the challenge of facilities capacity. Like for example, each, let's say, separator at one day I can handle, let's say, certain amount of water, certain amount of gas, right? I cannot separate more. And that's why, you know, I need to control my production in a way that I don't reach my you know, separator capacity. In certain fields where they have only gas cap, for example, if the production becomes high, they have to flare the gas, burn it, okay? Which is of course, you know, a big loss. So you need really to control your production in a way that I don't exceed or don't reach my facility's capacity, which is all separator capacity. We have the problem of the integrity of the assets, corrosion, erosion, scaling, etc. Okay, so as you can see here, there are a lot of challenges in any production system. So it's now not talking about, we're not talking about the individual wells, we're talking about the whole system, the whole production network. Okay, so that's why you will need to manage your facilities, your field, with constraints. Constraints are limitations, are, you know, conditions that you need your network to be produced with, so that, and at the same time you need to maximize your hydrocarbon production, right? So for example, you need to not to exceed drawdown limits, because in certain reservoirs, if the drawdown becomes a bit higher than, let's say, maybe 100 psi, 200 psi, 300 psi, then this will affect the integrity of the formation itself. There will be a lot of pressure drop, there will be a lot of turbulence, and then you will start producing sand, and then this is a major problem. You need to look into the shared common manifolds, and this is one of the examples I showed before. Okay, let's say the manifold itself can handle certain production flow rate, so you don't want to exceed that. You have the erosional velocity. If the production is very high and the pipeline is not big enough, all right, I will start having erosion in my pipeline, which is a major problem. Gas processing capacity or water handling, water injection limitation. So this is what we call